So let's get going. First of all, thank you for being here. This is our Temporal Understanding and Debugging Event Histories workshop. This is the first one. And yeah, my name is Tihomir. I'm a member of the Temporal Developer Success Team. So we basically provide community and also customer support for Temporal. So just kind of the first slide is I wanted to kind of point you to a couple of things. Temporal.io, the main Temporal website / community is where you can see how you can join our Slack. Oops, sorry, going back. And also our community forum. So if you have any questions, so you want to contact us at any point in time, that'll be a good link. We also have documentations at docs at Temporal.io and also our educational or learning material that we have at Learn Temporal.io. The slides that we're going to be showing today are all on GitHub. So this is the URL link. It's my personal GitHub / Event Histories workshop. And if you signed up for this one, you probably yesterday or today received an email for Event Histories Part 2 or Advanced or whatever it's called. It's going to take place on February 16th at the same time. It's also Thursday. Once I started doing the slides and preparing content for this workshop, I realized that there's so much stuff to do. And so this is going to be more like we're going to give a very good introduction and we're going to have samples and talk about a lot of very important stuff. And everything we talk about in this workshop is going to be a prerequisite if you join the second part, where we're just basically just going to look at event histories all day long. I mean, for the whole duration of the second part. So, being here and understanding what we go through now is kind of important. All right. So when we talk about event histories, it's honestly not the most kind of interesting or exciting subject, I would say, with Temporal. But in my opinion, it's probably one of the core concepts that you, as a user of Temporal, have to understand. Another thing kind of to bring up is when talking about event histories, we're going to have to touch on a lot of different parts of Temporal, how things work from the user perspective as you're writing your workflow code, for example, but as well as internals. So this is kind of going to jump sometimes. So if you're new to Temporal, we have Arohi here and watch chat, and Arohi is going to, during this workshop, put some links in the chat to different docs links that then you can, save and read upon if some of the concepts here you need some more kind of clarification about. So anyway, so what is an event history? An event history, basically every successful created workflow execution in Temporal has an event history. And the event history itself is the append-only log of all events that happen during a workflow execution. There are some event history guarantees. So for example, events are all in order as they're generated. So in the picture on the right-hand side, for example, you can see the event ordering in the web UI. This is a view from the web UI, that there are natural numbers order starting at the 1. Yes. So one thing about event histories is that already written events are immutable. So once Temporal service sizes, we'll see a lot of details about this, generates an event, persists and writes it into the event history, that event is immutable. No events can be added after a workflow execution completed. So yes, so once your workflow execution is done or has completed, whether successfully or fails or whatever, no new events can be generated in this event's history. And this event history is in sync with this thing called a mutable state, or the way you can think about it is like the server's view of the workflow state that includes, of course, all the information from the event history, but also includes a lot of additional information for fast lookup and things like that. And it's also cached on your history services. Every single event, that being its type and all of its attributes, as we'll go through it, are fully defined via protobuf. And we'll also share some links with you during the slide, or where you can actually see these definitions. So the event history in the end can be seen as the source of truth for your workflow execution. All right. So how, now that we kind of understand what a workflow history is, how are they used? So they're used by different parts of the temporal system. Number one is the server. If you don't mind muting yourself, please. Yeah. So from the server side, we use workflow histories for example, the workflow reset feature, where we kind of take an existing executions workflow history and recreate the mutable state from it for the new workflow execution up to the reset point. It's also used for XDC replications, where we push actual events from, let's say, one primary cluster to another. And also it's used for this archival feature, meaning we're storing the event histories in the bucket store, that being S3 or Google Cloud or whatever, if you're using that feature in OSS. From your workers perspective, that being the workers that you actually deploy and you register your workflows and activities with, that you're running on your side of the fence, event history is much more important and much more widely used. It is used for reconstructing workflow execution state. So meaning that because a workflow execution with temporal is not tied to a specific worker, workflow execution can be started, for example, it's on one worker and then continue under some certain circumstances on another one. So it's also used for workflow determinism, meaning the event history on the worker side is used to make sure that your workflow code, as far as, and we'll talk about the commands that your workflow code generates, matches that of the event history, which gives you the determinism factor of temporal. And also workers use event history to add this thing called worker or marker events, which are just SDK or specific events that the server does not really understand, but just blindly writes. But they're used for things like versioning, that you might be versioning your workflow, or patching, as it's called in some SDKs. Things were called side effects, some features where you can deterministically create or generate dynamic or random numbers, for example, random type of things. And then also for local activities, these are the type of activities that are fully executed and managed by your SDK, rather compared to like quote unquote normal activities. And also it can be used for testing and debugging, especially when you want to introduce things like versioning or patching. The SDKs provide a workflow replayer type of via their test environment that uses workflow histories as well. From the tooling side, of course, and I'm sure you all are familiar with, when starting to use Temporal, is viewing workflow histories via web UI. And it's typically how everybody, most of the people start seeing event histories in Temporal, but also via tooling, CLI, so through TCTL command, or you can actually get the raw history yourself, and we'll have a slide on that. We have your SDK code and create some custom visualization of the event histories if you wanted as well. So now, how are these event histories useful for us? Event histories are actually very important to understand the details and failures in your workflow. All right. Please mute yourself if you don't mind. Thank you. Another thing that event histories are very useful for is to understand what clients and workers were involved during your workflow execution. You can use it to detect workers being unavailable or overloaded, and that's also very, very interesting and important feature that we'll kind of address. And you can use it for things like, for example, improve your workflow design. You can see the event histories generated by your workflow execution and actually try to improve the design to make it, more performant. We'll talk about performance and event histories and things like that. So another thing that you can do is optimize your configurations. As you know, with Temporal, we have a lot of different configurations, such as for timeouts, like a workflow timeout, activity timeouts, child workflow timeouts. So looking at the event history, which provides a lot of information, and then seeing the patterns in your event histories as well, can actually be used to improve or optimize those types of configurations. And you can also, even with event histories, now you can't fully rely on this, but looking at an event history as the first thing can give you some indication of a possible failure, that being on the worker side or even on the server side. Now that, of course, we typically recommend to also look at your metrics and your own metrics, and also the temporal server and SDK metrics, to kind of make sure that what you're seeing in the event history is correct. But event histories are a pretty good indication as kind of like a first line of defense to possibly detect these types of issues. And of course, we talked about testing and debugging. So for people in OSS, we get asked a lot, okay, where is event history persisted? Events in the event history are generated and persisted in the history service. As you know, Temporal, as far as server goes, has different services that are fully independently scalable. And one of the probably main services has the history service, where these events are generated in persistence. And specifically, it's persistent in this thing called a shard, which is responsible for this specific workflow execution that you're looking at the event history for. As far as where, in what persistence store event histories are persisted, they're persisted in your primary, or when you have your configuration in the default persistence store. They're not persistent in visibility. If you're using, standard or enhanced visibility, they're not persisted either in your visibility database, or in if you're configuring enhanced visibility with Temporal with Elasticsearch, they're not pushed to Elasticsearch either. So on the right-hand side, we see specifics, a little bit more specific. It's the Temporal or your default or primary persistence store database in a table called history node. The data, it's stored as raw binary, as blob. And in the history, as we'll see throughout this presentation, the encoding is protobuf, and all the events and their attributes are fully defined via protobuf APIs. So they're fully defined, they're not just random. One thing that always comes up is, okay, once our by event history is stored in persistence, how long is it persisted? With Temporal, because you can have short or long-running executions, and long-running executions can take days or even years, the event history for a particular workflow execution is available as long as your execution is the running state. So it can practically be for years. Once the execution completes, the event history is available in the persistence store up to your namespace retention period. So every workflow execution that we start is executed given different parameters, one being the namespace where this execution should be running. Each namespace has different types of configurations, one being a retention period, which is in days. So once the workflow execution completes, we calculate the time of its removal based on the namespace retention. Before, of course, it's removed. If you're using the archival feature in OSS, it is shipped to your blob store that you have configured, and then by some background processes is removed from persistence. This really means that because you can query, actually, this is related to queries, you can actually query your workflow executions when they're completed as well. And that's if you don't mind muting yourselves, guys. Thank you so much. All right. Anyways, and there's some notes down there that could be useful as well. So now, how do we get or view our event histories? Of course, we said we have web UI, we can use CLI, and here's a command that I use a lot when we communicate with our community or users asking questions, that basically will get a workflow, an event history for a workflow execution, and push it into a JSON file locally that you can share or look in your IDs or whatever. Now, you can also get your event history for a workflow execution using SDK or client code via get workflow execution history request. This is the same thing that in some certain situations, same API call that your workers do when they need to get the workflow execution history from the service. As well, and we'll talk about that. But just note, if you do it, I see it a lot of times, and I've done it myself. This API get workflow execution history is paginated, and there is a default page size, meaning if your workflow histories or event histories are very large, you might have to do an iteration where you get multiple pages of event history to get the full all events for this particular execution. Now, event histories have limitations, and we talk about them a lot. One is the event count limit. As we've seen that an event history has an ID or identifier field, which is all the numbers that are in order, natural numbers. So this is the count, and each event history is per workflow execution, and this event count limit is 50K events, and it also has limitations on the size. So we said that the event histories are persisted in the database, so we can calculate, their blob size, and there is also a limit there for 50 megabytes. In both cases, it's important not to reach this limit as then service, because the server actually manages your workflow execution. When on new updates, let's say, or events having to be written into the history, these limits are checked, and your server might be terminating. It will terminate your workflow execution if this limit is reached. So what about performance, event history and performance? As we said with Temporal, you can have very long running workflow executions, but also you can have very short ones that do a lot of stuff. So event history itself, or the number of events that get generated and persisted into the event history, can actually grow over time a lot. And large event histories can have an implication on your workflow execution performance. So let's see from the server side or the service side what large event histories and have to deal about. For example, like we said on reset, we have to reconstruct mutable state or the server representation from event history of an existing execution. And when our event histories are large, that might take more time. The transfer to your archival endpoints, given the size or the count or how large your event histories are, can have performance implications. And especially on the worker side, in some conditions, when your workers have to ask the service for full event histories in order to be able to continue workflow execution, is returning that can also add, and that's probably one thing where you see most of the performance issues as far as your latencies goes for workflow tasks and your overall latencies of your workflow execution. So on the worker side, of course, we said pulling full history from the service. For very large event histories, this can actually cause different timeouts. And I have here workflow task in parentheses because we will actually have specific slides of what workflow task is. And as we said, it can increase latencies. On the tooling perspective, very large event histories take more time to load and display and things like that. Now, the overall recommendation is per single workflow execution not to exceed about 10K events. But Temporal, does provide some event history partitioning techniques that you can apply to your workflow code, such as using child workflows or nested workflows. And this feature called Continuous New that can help you with that. And it is something that you should consider when you even start working or start writing your workflows that you think, not right off but the bat, but once you see that you're running into your workflow executions to create large event histories, it's something you can start thinking about how to partition using that. More stuff about performance. Oh, okay. So there's a little bit of duplication here, but there is also some event history can help you with knowing when to partition your execution history on the bottom part. And we'll talk about what a workflow task started event is, but there are some attributes such as an event ID or the count. So your execution event history has a count which goes from 1 to n. So you can see that in order to see, okay, have I reached some number where I need to start thinking about partitioning? But there is also a couple of other attributes. Some of them are still in the works, so you can't really fully rely on them, but just FYI, it's such as history size in bytes that could help with the determining when we need to partition our event histories based on the size of our event history. And then also there is a parameter called suggested continuous new, which is currently in the works. And they can, it's basically a Boolean that will allow you, hopefully in the future, to kind of have a suggestion, so you don't have to kind of watch all these things yourself. All right, let's see the next slide. All right, so next thing I want to talk about is the event structure. So each event in the event history has a very particular structure. On the left-hand side, it has some core attributes. This is, as we talked about, the event ID. There is every single event in the event history is going to have an event time. Now, this particular time is not the time when, for example, the service requests gets a request to do something, but it is the actual time when the event is generated, and particularly in the history service of your temporal cluster. And then every single event has event types, and during this workshop we will go through the most important event types that we typically look at. So those are the core attributes. There are more, but these three are basically kind of the most important things you're going to look at. And then each event in the event history has specific attributes based on its type. So given a type of an event in the history, it's going to have a lot of different attributes and we'll see a lot of them, don't worry. Now, all of these event structure is fully defined in protobuf with Temporal, and here is the GitHub URL in the /API repository for Temporal. On the right-hand side, we see kind of representation of an event in the event history in JSON format. So we have our core attributes, and given our type, event type being let's say workflow execution started event, this event is going to have its type specific attributes that we're going to go over. Another thing that's very important when you start looking at event histories and individual event attributes, it's default values. So, there is a lot of defaults. Things like workflow timeouts, if you don't specify them explicitly, have some defaults. For example, the workflow execution, a run timeout, if you don't explicitly define them in your client code when you request start of a workflow execution, it's going to basically have timeouts. I think there's like 10 years or something like that. Activity timeouts, activity have some default, even though you have to at least define one of the activity timeouts, for example, start to close. If you don't have to define all the activity timeouts, and some are also going to have default values when you start looking at the attributes of this particular events for activities. And also with Temporal, we do have, of course, default activity retries, which also have defaults. Also on the right-hand side, you see, for example, that even though in this case, we did not explicitly define in our code the activity retry options through activity configuration, you will still see them in the event history, and it's going to have some values. So this is currently a little bit of a confusing thing, but we do have on the bottom left corner, I put a docs link to a page that does have some references to these default values, so you can figure out, okay, is 1 second for initial interval default value? Yeah, it is, and things like that. So you don't have to think that you explicitly define this in your code. Now, one more important thing about events in the event history is event correlation. So when you start writing your workflows with Temporal, it is not only synchronous. You can write async activity invocations, child workflow invocations. You can create a timer and then wait for it completely, maybe an hour later and things like that. So Temporal is, you write your code in an async way, and some of our SDKs even by default are all async invocations unless you specifically want to make them synchronous. Because of that, the events in the event history are, even though the event ID is in order, the events themselves are a lot of times not in order because they happen at different times. So the event correlation is going to allow you, when you start looking at event histories, to actually associate or correlate multiple relevant events in its history. And correlation with, if you start looking at an event history for a single workflow execution, this correlation is provided within the single execution itself. So for example, in the bottom left, we can see that we can use event correlation to correlate 3 events in the event history. They're associated with the same activity, invocation, and its completion. But also the event history, as we will see, also includes type attributes that help us with correlating multiple related executions. So for example, we can use the event history of a parent workflow, and we can see some certain type attributes there that would let us know, hey, how do I associate my parent invocation with, for example, a child workflow invocation and things like that. Or in case of, let's say, cron jobs, or continue the executions and things like that. The event history is really on the bottom right. We see that event correlation can be used for display, reviewing, and this is just a screenshot of the Web UI compact, where, for example, we see the highlighted is an activity event that is correlated between 3 of the events that are associated for that particular activity invocation that happened. All right, so what are some of these event correlation type attributes that you're looking for? There's actually a number of them. Things like started event ID, scheduled event ID, initiated event ID. So basically, you can correlate completion of, let's say, a child workflow execution that was invoked async in your workflow code to the particular event where it was initiated. Parent-child relationships, continuous new, as we said, and in terms of, if you're sometimes using the reset functionality of the reset execution, you can actually see the original execution run ID type attribute, which will give you a run ID of the completed, for example, execution where we apply the reset on. And on the bottom left and right, you can see that that's reflected also in the history, and you would get the event IDs for the correlated events in this case. All right, so now we get to our event types. So our event type, we have a bunch of event types, and we're going to go through the most important one, but the event types have to deal with workflow execution, workflow tasks, activities, timers, marker events, which are just, as we said, SDK-specific events and things like that. So let's take a look first at our workflow type attributes. We have workflow execution started event, and it has a bunch of different attributes. I didn't put all of them down, but these are some of the ones that we're looking at when we start debugging event histories. Probably first one that we're looking at is probably identity. I mean, of course, the workflow type, the task queue, but identity is important. That will probably give you an idea of the client identity they actually requested the workflow execution. But also things like retry policy, which is typically not recommended to have for workflow executions, but you can also see related attempt count. But also you can see, for example, your memo and the search attributes that were passed alongside with this request to invoke, to start workflow execution from the client. There is a bunch of different completion events for a workflow execution. But in the notes below, you can see that workflow execution started event is always going to be the first one in your event history. And one of these completion events, it's always going to be the last one in for an event history for execution if it completed. That means successfully or it failed or things like that. Now for activities, it's a similar thing. We have an activity task scheduled event that has different type attributes. For example, activity type that will let you know, hey, what is the type of the activity that your workflow code requested to be invoked or scheduled for invocation, execution, and things like that. And then we also have a bunch of different completion specific event type attributes. That especially one that I want to bring up is activity task failed. So you can, through your event history, see the failure, what happened that caused this activity to fail. Now, this, you might think like in the completion, why is activity task started event in the completion? part of the activity event types, and this is not a typo. This is actually due to an event history optimization. We talked earlier about that in a single event history for a workflow execution has its limitations. And we also know that with temporal, our activities have default retries. And for example, if we in each activity invocation or requested invocation has, I believe 3 different events that get generated and persisted and added to the event history. So if we actually recorded every single activity retry, we would very easily, in some cases, reach our limitations of the event history count. So for that is one important thing to understand when we're looking at your event history is that this activity test started event is not written into the history until actually it completes or fails. And that is written after all of its retries. So one of the things to look, if you have, for example, an activity test scheduled event is the last event in your workflow history, but there is no activity test started event, to watch the pending activities. And you can watch pending activities on the right-hand side in the image. We have the web UI on the top. You can also get the pending activity information about TCTL as well. And there is also via your SDK code for APIs. You can use the describe workflow execution API, which result for a particular workflow ID and run ID. So for a particular execution, that will give you pending activity information as well. And that pending activity is going to tell you which activity or activities are currently being retried and have not completed yet, and things like that, or even will calculate the time and will allow you to see it when the next attempt of an activity retry will happen. On the left-hand side, we see that on activity test started event, you will see the attempt equals 4. So in this case, when our activity invocation completed, it completed after 4 retries. So now just going, I know this is boring, but we'll get much more exciting here. So these are the kind of most important type specific attributes for child workflow related events. So we have child workflow execution initiated event, which is when your workflow code in your workflow code, you want to actually invoke a child workflow. This is the event that gets generated when actually the start or the execution of your child workflow start. We have a child workflow execution started event. And then similarly to activities, we have a number of completion events. So a child workflow invocation can complete successfully, it can fail where you can see the failures, it can time out and things like that, or it can be terminated as well. Now, the event history optimization for child workflows is child workflows can, when a parent evokes a child workflow, this child workflow can retry or can call this continue as new, but to the parent, it will just look at this as a single child workflow invocation or execution. Different than activities, for child workflows, we do not record, for example, retry counts and number of continuous news and stuff like that. But through event history, you can definitely get this information, such as how many times this child workflow was retried or how many times it called a continuous new, as far as continuing its invocation as a new child workflow execution through the child workflow histories. Just for timers, again, we have timer started, and then we have the completion events of timer fired when the timer was that was created on the server side was fired, or through also workflow code, you can cancel, for example, a timer that you create as well. Now, marker events are a little bit different. Marker events, as we said, are only SDK specific event types. They're used for things like local activity, side effects, versioning. So basically, they're for SDK to write and SDK to interpret itself. Now, what about queries? Well, queries are not recorded in event history. However, you can query running and completed workflow executions. The completed ones, you can, as we talked about, how long do we actually keep our event histories in our persistence up to the namespace retention. You can query complete the workflow up to that. And yeah, So query timeouts, however, can happen, and they can relate to, for example, you can see through workflow tasks, client errors. So in the client errors, you can see things like a lot of times like context deadline exceeded errors that can be actually related when your client queries your workflow execution. And the event histories can a lot of times help with that as well when you look at them to figure out what could be possible cause for that. For signals, we have workflow execution signaled event that's a single one, and just not all signals are recorded in the event history for a workflow execution, regardless if you have a signal handler or not. So just be wary of that when you expose third party or some clients to actually signal your workflow execution. They can easily probably send or bombard your executions with signals, reaching some of the event history limitations that we talked about. And of course, signals are only recorded while the workflow execution is running. Now, here is probably the most confusing part of our event histories, and just in Temporal in general, is workflow task events. If we look at the event history or start looking at them, you will see, for example, events about activities, child workflows, signals, all these things that we talked about before. But in the midst of that, you will see a whole bunch of these workflow task-related events into the history. And yes, they can seem like noise, especially for larger or longer, long-running workflow execution. There could be a ton of them, but they're actually very important. And one of the things, if you get something out of this workshop, I think this is very important part of it. So the workflow task-related events in the history can help you detect a lot of different things. Number one, you can see the worker identity. You can specifically see what particular worker that you're deploying on your side is responsible or is involved in the execution of your workflow. You can see if the workers are overloaded even, or at some point through workflow tasks, things like timeouts, you can see, hey, are my workers even down? Now, we again don't suggest to just look at the event history for that, but also, of course, your SDK and server metrics and things like that. But this can be a pretty good starting point for an indication of things like that. It can help you, for example, with seeing that one of your local activities is retrying. It can help the workflow task has a workflow task failed event, which can help you determine, hey, why are my workflow stuck on, let's say, some sort of workflow error, that business level error, or even non-deterministic type of issues. It can show even data converter failure. So as your payloads are going from server to being delivered to your workers, for certain new events, that they do go through your data converters, and you can detect possible issues there, as well as something called a workflow execution deadlock detection as well, that manifests itself as a possibly failure of workflow tasks. So workflow tasks are very important, what I'm trying to say. Now, to start explaining workflow tasks, we have to start talking about workflow execution. So workflow execution is created and persisted on the server. So a client makes a request, the worker actually is responsible for creating this workflow execution, creating the event history, persisting it, and things like that. The workflow execution itself, or any workflow execution, is also completed by the server. So when you have actually a return statement from your workflow function in your code, does not mean that your workflow execution at that point is actually completed. What that means is that your workers are going to communicate with the server, telling him, hey, I've completed everything I could for this workflow execution as far as your workflow code goes. Please complete this workflow execution for me. So it's more of a request rather than anything in the server actually is going to complete the execution for you. However, your workers are responsible for executing your workflow code. So the workflow execution progress itself is depending on both your server and your workers. Now, so I didn't remove one of the slides. So when we talk about now, what is a workflow task? A workflow task is a contract through which the server and your workers communicate together to drive workflow executions to completion. And this might be a little bit overloaded yet, but probably the most simplistic definition of a workflow task could be just, hey, when your workers are executing a workflow code during your workflow execution. But let's get to kind of the bottom of this. And this slide has a little bit of animation, and this is not supposed to be a very, very detailed view of what happens. but it's supposed to really give you a high-level picture of what happens during a workflow execution that will give you an idea actually what a workflow task is. So on the left-hand side, we have our client. This is some sort of client that's going to make a request for execution of one of our workflows. And we have your workers that you're deploying, one or more. They're constantly polling the service for new work to do. On the right-hand side, we do see our temporal server. It has different services such as front-end history and matching services. And we also see the persistence store on the right. Let's say this is our primary persistence. The way we're going to explain workflow tests or start explaining is, let's say our client makes a start workflow execution request, passing in things that you do in your workflow code, such as the namespace name and workflow ID. At this point, all the calls from anybody, from your workers or any clients, go through Temporal to this front-end service, and it's going to reach a front-end host. The front-end host is then going to deliver this request from the client to using the namespace and workflow ID. It's going to basically figure out which one of your history hosts, and it's particularly which shard is going to be responsible for this workflow execution that the client requested. In the shard itself, we're going to create the event history, EH, mutable state as well, and we're going to persist it. At that point on the bottom right, we have an event history with a first event called workflow execution started, meaning that the service has created this workflow execution upon client request. At the same time, and again, there's so much more involved in this. This is just really a high-level picture. Each workflow execution has a timer. So if, for example, you define a workflow run or execution timeout, these timers are created and durably persisted within the history service and the shard itself that's responsible for this workflow execution. At that point, the server has really done everything it can. It created and persisted this workflow execution, and now it's time for our workers to start executing a workflow code. For this to happen within the shard, we create a task. A task is actually created in these things called transfer queues, and we're not going to go into that, but basically a task that needs to be delivered through the workers. The way the server communicates with your workers is through the matching things called task queues. Those task queues you all guys are very familiar with because you actually have to define the task queue names as strings when you start workflow execution, when you start create your workers and things like that. So this task is then delivered from the history host to one of the matching hosts. Again, there's some algorithms going on there and a lot more involved, but basically delivers it to a matching host on a task queue that your workers poll on. Our workers on the bottom left, let's say, poll this task. And at this point, we see in the workflow execution history, we have a workflow test started. And I'm sorry I jumped the gun. When this task was moved from history to matching, we have written in our workflow history a workflow test scheduled event, meaning that the service has scheduled this particular task to be picked up by our workers. Workflow test started event is written when this poll workflow task queue requests that the workers do pick up a task. And at this point, we also create, you've seen the shard, the workflow task timer, a timer for the workflow task, meaning that the service is going to basically create a timer that is going to let us know, hey, if this worker goes down, or once it picks up the workflow task to start writing our workflow code is no longer available for some reason, that we time out this task. So this is a timer that allows us to know, hey, if, for example, we don't get a response from our worker within typically 10 seconds as the default, we're going to place this workflow task back on this matching host task queue in order for another worker that's available to pick it up and be able to make forward progress for our workflow execution. When the worker has executed your code, the worker responds back via gRPC request, respond workflow task completed, including some commands that we will look at. And this is going to write on the bottom right in our event history, a workflow task completed. So at this point, our workflow task is completed and we can start, and we'll see here in a second what happens after that. So the workflow task itself, if we've seen, goes from workflow task scheduled to workflow task completed. It could be also failed or timed out and things like that. But this is a mechanism to make forward progress of execution and for a server to be able to deliver new events to your workers. Then I use these new events to execute your workflow code, and your worker to communicate back to the server, says, hey, I've done everything I can do. Please perform these particular things for me that are delivered via these commands. So kind of to understand a little bit more, so on the right, we have our event history. So what we have is what we had on the previous slide. Let's say workflow execution started, and which means the server created our workflow execution. We have a workflow task scheduled, which means we placed it on the matching host task queue. And now we have a third event, which is called workflow task started, meaning our worker has picked up our workflow task. On the left-hand side, we see very, very dummy Go code. And basically, this is a workflow function, and it does a couple of things. And let's see how this works. So when our workflow task started is written in the event history, we know that our worker has picked up this task and starts executing our workflow code. On the bottom side, you'll see the commands generated for each line that our worker executes. So the first line is going to call workflow execute activity, which is an async invocation of an activity. This is going to generate a particular command called schedule activity task. Then we have two more of those that our worker goes to. Now, these are not blocking calls because these invocations of these activities, we're invoking them async. And then, so we generate our three commands, and then our workflow worker is going to run the workflow.sleep command. This is actually a blocking command. And for this, we're also going to generate an event called called start timer command. At this point, our worker says, look, I've done everything I can. I have to actually create a timer for my 5 seconds. This timer has to be durably created and persistent on the server side. So the worker what is going to do, what we saw in previous slide, is going to respond back to the service with workflow task completed and pass all of these 5 commands to the service. These then, of course, then go from front end to history, and each one of these commands then is going to actually trigger a generation and persistence of new events, corresponding events in the event history. So we have a workflow task completed, which means the worker has responded with completion of this particular workflow task. And then we're going to see 4 events in our history: activity task scheduled, corresponding to the schedule activity task commands, and the timer started event number 8, which corresponds to the command that our worker asked the server to do, which is to create a timer for workflow.sleep. All right, so another thing I wanted to talk about is buffered events, and this is very important to understand event histories. Now, Temporal is a very dynamic system. So let's say, again, we're in a situation where our worker has picked up the first workflow task and starting executing this code that we went through in the previous slide. However, what if at the same time, while your worker is executing this code or this workflow task, we have a client that sends signal to our workflow? So in this case, on the bottom left, we have a client that sends 2 signals to this workflow execution. Now, these are 2 new events that have to be delivered through our workflow, so through our worker, so it can actually call our workflow signal handlers to handle these events. So the workflow task, and we talked about, is a contract, is actually a contract. One of the parts of this contract is that while the worker is executing a workflow code, so between workflow task started and completed or failed, the events that come in, such as these 2 signals, are going to be generated and buffered, but they're not going to be written into the event history until your worker responds with workflow task that it completed the workflow task, or it times out in case of timeouts and things like that. At this point, again, when the worker actually completes the workflow task, we'll see workflow task completed. The next thing is we will add those events that were generated based on the commands or based on your business logic or the workflow code that was executed during this workflow task. And after this, now we're going to flush our buffered events, and you're going to see 2 workflow execution signal events in your event history. So this is kind of important when you see the ordering, especially what comes after workflow task completed events. You can basically figure out which events that come after this were generated due to the commands that our worker gave us or things to do, and which after that you can figure out kind of what events were buffered. Now, these are not only signals, because buffered events can be things like, I'm going to hurry up, we only have a couple more minutes. Buffered events can be things like async activity completions, async child workflow completions, timer completions, and things like that. Things basically that happened while our worker was busy executing these 4 or 5 lines or a workflow code that corresponded to a workflow task. So hopefully that kind of makes sense. All right, so this is basically the same contract that we talked about before, that while your worker is executing a workflow code, all the new events are going to be buffered that are written after the workflow task completes. And this actually is a mechanism, or this contract, that allows the server to deliver all the new events to your workers after they have been generated. Now, so we talked about this just real quick. So the events after the workflow task, let's say completed event, can be 0 or more events generated from commands, and 0 or more buffered events. And we'll check that in our example. So just to go real quick to kind of complete the loop, we're almost done here. These are some workflow task specific event and their attributes. So we have with the schedule, started, completed, timed out, and failed, where you can see the failure. For workflow task started, we said the important type attribute is the identity that will give you the identity of the worker that picked up this workflow task and started executing your code. All right, so we have a couple more minutes, 5 more minutes. I'm sorry, we're kind of running, to the end, but let's now put it all together. And for this, I have a workflow execution here that now we can apply all the things that we learned to actually just look at the event history, and through and learn how with this event history we can actually figure out exactly what happened during our workflow execution. So this is a web UI, and we have a workflow type of my workflow. We have a run ID, which is generated by the service. We have start and close time, which are actually pulled from the visibility store and the task queue and things like that. So let's see actually what we can figure out from the event history. The first event, as we said, is always going to be workflow execution started. One of the things here is the identity that I would probably first look at. That would tell me which client in this client called a chapter 1 client made this request to which triggered execution of this workflow execution. And so the next thing we see is our 3 workflow task-based events. So that right away means, hey, the service have put the task to matching, worker picked it up. We have the workflow task started event. We can again look at the identity task, and then after that we can see our events that were generated based on the commands. So we see a marker recorded event here with the marker name side effect. So this basically tells us that the first thing our workflow function is doing is called workflow side effect to, let's say, generate a random number. And then we see a timer started event, which is also event generated from our workflow code, which is probably to create a timer based on, let's say, this value calculated in a side effect. Right after this, so we said the first come the events generated from the commands. Right after this, we see our buffered events. So we see workflow execution signaled, which happened while our worker was executing these 2 lines of code, or a number of lines of code in this case. Now, this workflow execution signal event has to be delivered to our workers. So the service is going to schedule another workflow task that gets picked up by a worker. And now what we see is after workflow task completed, again, a timer fired event. Now, this actually means this is a buffered event. So there was nothing, because I guess we were waiting on a sleep in this code with timer started. In the meantime, we couldn't progress our workflow execution because workflow sleep is a blocking event. However, this is a buffered event saying during this workflow task, well, our timer fired on the server side, and now we have to deliver this timer fired event to our worker, telling him, hey, the timer is fired, you can unblock the sleep. So again, we have a workflow task or this contract of communication between the server and our workers. And after a workflow task completed, we see an event generated by from the commands or workflow code, which is activity task scheduled, meaning that after unblocking from, let's say, our workflow sleep, in this particular workflow task, we actually execute a line of code to invoke an activity type, activity A. Then we see activity test started and completed, which most of the time means that this is a sync invocation. So our workflow code is basically waiting for this activity to complete to make progress. And these two here, started and completed, are then events also generated when the service has been notified the activity has been picked up and activity code execution has started on the activity worker, and this is when it completed. At this point, we have to deliver these two tasks to the worker, telling the worker that, hey, the activity that you actually wanted to invoke has been completed. So we have another workflow task here that then delivers these two events to our workers. After that, our workers in here were able to most likely unblock the wait on our activity to complete, assign the activity results back in our workflow state. And here we say start child workflow execution initiated. This really is an event generated from our workflow code, meaning after, let's say, execute activity, which was blocking, now our workflow code is going to start a child workflow invocation. So you see I know we're over time, but just looking at the event histories, you can follow, and once you understand what are the different events and their event types, and also looking at some of their core attributes, we can actually really figure out what happened during the workflow execution. Now, of course, the sample that we gave, given the time now, is a happy example. But again, what I wanted to show is for the event histories part 2, if you're interested, we're actually going to look at failure scenarios and things that I wanted to actually cover in this, but due to time, we kind of ran over already, and there was a lot of material to cover and things like that. And yes, so the event histories part 2, we will do all that. So I'll stop sharing my screen now. I see there was a lot of stuff going on in chat. Yeah, if anybody has any questions and wants to ask them live, please go ahead. I'll be around for at least 10 more minutes. But again, thank you, and I'll stop recording now. And yeah, I hope this was helpful to you.